Hi there, I'm Ian Whitney. I work with Academic Support Resources. For about 5 years, I was the manager of the custom solutions team there. And recently, I took a new job with an ASR as an integration architect. I spent a lot of time thinking and working with Apache Kafka, and I'm here today to talk about one aspect of that, which is Kafka Connect. Let's talk a little bit about Kafka first. It was originally written within LinkedIn as a data integration platform. Since then, it's moved to open source through Apache. And if you go to the main web page, you will see that its main selling points are that it's highly scalable, highly reliable, and highly available. They also say that it's used by about 80% of the Fortune 100 companies. And as a result, it's probably getting something like trillions of transactions a day. So it's something that is heavily used and heavily tested. A detail about Kafka that we need to talk about is how it stores data. It stores its data in what it calls topics. And for those of us that come from a database background, you can pretty much think of these like tables. There are some differences, though. The most important one is how long you retain data. And within Kafka, that's a configurable setting by topic. So I could retain data forever, or for a week, or for 90 days, or for 1 minute, or 3 milliseconds, or whatever I want to configure that to. And if you've used a message queuing system, there's some similarities there between topics as well. But the main difference there is that with a message queuing system, you can only read the message once. With a Kafka topic, you can read the message as many times as you want while the data is retained. Another important detail is that data, once written to a topic, is immutable, and the order of that data can't be changed, can't be edited, it can't be deleted. As a result, you get some interesting side effects that fall out of that we're going to see a little bit later on. So Connect was written about 5 or 6 years ago, and it was written after Kafka had been around for a little while, and people noticed that 80% of what people were doing with Kafka was very similar. It was, I want to take data from here and I want to move it to there. And for the people that were doing this work, 80% of their work was pretty much boilerplate that they just had to keep rewriting. And that is stuff like, how do I connect to Kafka? How do I connect to a database? How do I take new data and write it to a Kafka topic? How do I read that data later on? And so the Kafka Connect API took those really common boilerplate implementations and put them all into one place that kind of now manages all of this stuff for you. So you now have this simple tool called Connect, where all you need to do is provide a configuration file that says, here's the details about my job that are unique to this one job, and then Connect spins up a worker, and that does all of the work. And I said worker here. Kafka Connect has two different kinds of workers. There are sources and there are sinks. Now, a source in Connect terminology is something that takes the data from somewhere else and puts it into Kafka. That somewhere else can be a lot of different things: databases, key value stores, external systems, message queues, files. There's a lot of options. On the flip side is a sink worker, and what a sink worker does is it takes the data from Kafka and puts it into another place. And that list of places looks a lot like our options for sources: databases, key value stores, external systems, and the like. But remember, I said that data can be retained for as long as you want and multiple people can read it. As a result, you can actually have multiple sink workers all reading from the same topic, all sending that data to different locations. So maybe you have data that comes in and you want to write it off to an operational data store, but you also want to write it to your data lake and you want to write it to Splunk and whatever. You can do all of those things. The custom solutions team at ASR has used Kafka for about 4 or 5 years now, and we have some good examples of production code that's using Kafka Connect. Our main one and our first one was using a source worker to pull data from a vendor's SQL Server database. And we also have a couple sync workers. One's taking application logs and putting that stuff into Splunk, where we can write alerting and reporting on top of that. We have a sync worker that's taking event stream data from one of our applications and sending that out to Amazon SQS for vendors to read. And we also have a source worker that's pulling data from Amazon SQS, and we're using that as a work queue for one of our applications. Now, as I mentioned, there's lots of different places you can get data from and send data to, and that list, the URL down there has a list of most of them. Confluent is a Kafka vendor that was created by the people who wrote Kafka initially, and as a result, they have a really wealth of resources and documentation on their site. If you go to that list, you'll see all the different Connect workers that are available. I recommend filtering down to just the open source ones, though. Confluent is a vendor, and they will happily sell you a lot of their own connectors. So if you filter to open source, then you won't see the ones you have to pay for. Today, we're going to demo the JDBC source and sync workers. And we're going to do that by moving data from hotel dev to hotel test. Now, this demo involves a lot of different windows and a lot of moving parts, so I recorded all of that. So what we'll do is we'll watch the movie of the demo and then we'll come back. In this demo, we're going to be getting data from Oracle's hotel dev and putting that data into Kafka. And then we'll put that data from Kafka into hotel test. Let's start off by looking at the data that I have in hotel dev. My table people here is pretty straightforward. It has an ID column that's an auto-incrementing primary key. Name is just a string. Deleted is a Boolean column that I'm using to indicate soft deletion. 0 means it's not deleted, 1 means it is deleted. Created at indicates when the record was first inserted, and updated at is a timestamp that shows when the record was last updated. So if we're going to put the data into hotel test, let's take a look and see what the data looks like right now in hotel test. And I'll just select star from people here. And we can see that the table doesn't currently exist in hotel test. For us to move the data from hotel dev into Kafka, we need to create a source worker in Kafka Connect. And to do that, we use a configuration file. This is our source configuration file. It's pretty straightforward, but let's talk through it really quick. There are 3 lines here at the top that tell Kafka the name of the worker, what type of worker it is, in this case a JDBC source worker, and where we're going to put the data that it finds. These 6 lines tell Kafka Connect how to first find the data and how to identify updated rows or new rows. Our query is very straightforward. Select star from people. And then we're using the updated at column as a timestamp to identify updated records. And then we're using the ID column as an incrementing column to identify new records. We're checking for new data every 1,000 milliseconds or 1 second. And then this last line is an Oracle configuration option. These last 3 lines tell Kafka Connect how to connect to the database. It's a JDBC connection string with the host name, username, and password. And I've clearly elided the password here. We're going to use that config file to create a new source worker in Kafka Connect. And we do that through a REST API call. And that's what I have at the top of the screen. At the bottom of the screen, I have a small command line interface that's going to show us any data that gets written to that IDEAA.people topic, where all of our data is going to end up. It's running now, but it's not showing us any data because no data exists in the topic yet. For us to put data there, we have to start our worker. So let's do that now. Once the worker started, it takes about a second for data to appear, and there it is. And you'll see it looks just like it does at the database. We have an ID value, a name value, deleted, and we also have created at and updated at. Those last 2 are showing as long integers, but they still represent the same timestamp value that we saw in the Oracle database. With our source worker now up and running, we can insert new data into hotel dev, and we should see that appear in the topic. First, though, we have to remember to commit the record. And once we do, it appears quite quickly in our Kafka topic. We can also then change that record. And once we commit that, we'll see that appear as well. Notice here that both states of that record appear in the Kafka topic. Remember earlier that I mentioned that Kafka topics are immutable. Once I've written a record to it, I can't delete it or change it. So I have both states of the data here. This is a fantastic way to see the history of data changes in your database in a Kafka topic, because you can see every state that the data row has ever been in. With our data now properly being sent from hotel dev to Kafka, we want to take that data from Kafka and send it to hotel test. For that, we need a sync worker. And for that, we need a configuration file, just like we did for the source. This is our sync configuration file. It has a name. These next lines around connecting to the database and the sync connector, very similar to what we saw before. We have a topic that we're getting the data from. That's our IDEAA.people topic that we've been looking at up to now. And then these ones are unique to our sync configuration. We're telling our sync worker, here's how you insert data to the database. Instead of just inserting a new row, do an upsert, which means you insert a new row if that row doesn't exist, or you update the row if it already does exist. So we have to have a way of identifying if the row exists or not, and for that we're using our ID column, our primary key that auto-increments in the hotel dev database. This tells Kafka to create the table people if it doesn't already exist in hotel test. Just as we did with our source worker, we create our sync worker by taking that config file and putting it into the REST API. Down at the bottom, I have hotel test, which, if you remember correctly, doesn't have a people table at the time. Let's go ahead and put that config worker into our REST API and see what happens. So if we query from people in hotel test, and there's our data, exactly the same way as it appears in hotel dev. I want to point out that first row with the ID of 21. Note that it has the name of updated, which is what we changed that row to in hotel dev. Thanks to the upsert functionality, Kafka was able to identify that that row had changed from new record to updated and applied the latest change to our table here. With our source and sync working, let's make some changes in hotel dev and see if they appear in hotel test. I'll quickly update the deleted column to set it to 1 for one of our records to show that it has been soft deleted. If I select from people, I see that that change has now been moved over to hotel test. But what happens if I delete a row for real? I can see that the row has been removed from our hotel dev table, but it still exists in our hotel test table. And that is one of the interesting real-world complications that a demo doesn't quite capture. Demos are great for showing off some of the easy, fun-to-do stuff, but they don't really dig into the real-world problems that we face every day. So let's wrap up the demo and talk about some of those real-world problems. Right, great. So our demo, as most demos do, made things look pretty easy. But at the end there, I showed off one of the real-world wrinkles that you really do have to take into account with something like Connect and the JDBC source and sync. You might have thought of some other real-world considerations, and I'll talk about some of those later on, but I want to focus on specifically that hard delete problem that we ran into. And to do that, it's going to help if we kind of understand deeper what our source and our sync workers are doing. So, when we set up our source worker, we had a config option that was your query, and that was just select star from people. But what Connect executes really under the hood when it's doing its stuff every second is select star from people where updated at is greater than the last time I checked, or the ID is bigger than the biggest ID I've ever seen. And any rows that are returned by that lower query get written to our Kafka topic. And obviously that query is never going to return something that got hard deleted. No select query is going to return something that got deleted from your database. And you also need a couple other things for this to work, right? You need an updated at column so that we can identify rows that have changed, and you need an auto-incrementing primary key to see when a row got inserted. On the flip side, we have our sync worker, and here's the command that our sync worker executes. It's using Oracle's merge syntax, which is how Oracle implements upsert functionality. The really important thing here is that first line, ID equals 21. And that's how this command is identifying if the row exists or not. And if it exists, it updates that row with new values. If it doesn't exist, then it inserts a new row with those values. So for upsert to work, you have to have some sort of way of uniquely identifying a row in your data. If you have a database that doesn't have those things, there are some possible solutions, and we'll talk through some options here from easiest to hardest. The easiest, if you're on Oracle, is to use something like Aura Row SCN. Now, that's a functionality that's unique to Oracle, where every transaction is given a monotonically increasing number. So you insert a row, it has Aura Row SCN1. You insert a second row, it has SCN2. You update that first row, and now it has Aura Row CN3, because that's the ID of the transaction that just got applied to it. As a result, you can use that number to identify both inserts and updated records, similar to how we were using the ID and the updated at values before. You're still not going to get hard deletes this way, right? The data's gone. You're just not going to be able to identify that. And you're still going to need a primary key to use that upsert functionality on your source database. And also, a downside here is this is Oracle specific. I know, for example, SQL Server doesn't implement functionality like this, and I'm not sure about other relational databases. Another option is to do bulk imports. Now, our worker was doing what's called incremental updates. So it looks for new records or updated records on a really quick schedule. You can go to a bulk import where you say, just get all data from the table and shove it in a topic and then shove that into my database. You do that on a slower schedule because you're getting so much more data. But the nice thing about this approach is that you do get all updates, inserts, and deletes. And you can uniquely identify the version, so you can say, okay, here's my latest version, here's the previous version, here's the version before that. Because you have full table contents, you know exactly what is in the table, so you know if a record got deleted. And effectively, you've recreated PS Snap here, right? And the downside is there, just like PS Snap, this is not a near live solution. This takes some time to run, and you're probably going to want to do it during some downtime. It's just not going to be a near live sort of thing for you. If you want to kind of get the best of both worlds, you can stop querying the table and you can go down a level to what's called CDC workers, or change data capture workers. Now, these are workers like our JDBC worker, but instead of querying the database, they are pulling the database's own replication log, which is where the database stores all the details about what inserts, updates, and deletes have happened inside that database. As a result, the source worker is able to ingest everything that's happened in the database, and then the sync worker is able to replay all of those exact same changes to a target database. With that means you get updates, inserts, and deletes, because all three of those things are tracked in the replication logs. And you also get something that's near live, because you're able to grab new entries from that log as soon as they happen and replay them to your source database. Some downsides of this approach, and why you might not want to do it, is it does require some escalated database access. My account, for example, can't just query database replication logs. I don't have access. And the configuration is a little bit more complex than the JDBC source and sync workers that I was demoing. But there are open source adapters that work for CDC layer stuff against all the major database platforms, including Oracle. Finally, you could do something like rolling your own. As I said earlier, Connect was meant to handle kind of the 80% most common use cases. And you might have a use case for getting data into or out of Kafka that doesn't really fall into that 80%. You can always just write your own. Get the data yourself, push it into Kafka, get the data out of Kafka, put it wherever you want. As a result, this is going to implement exactly the logic you need. My team has done this several times. But the downside is that the writing and the maintenance of that code is going to be on you. You're responsible for a lot more stuff here than you would be going through Connect. But in some cases, that's the only way to make it work. A couple other little things you may have thought of. Data types. We were pulling from Oracle and going to Oracle, so the data types are the same. But what if you're going from Oracle to MySQL, which has some different databases? In most cases, that JDBC sync worker is just going to handle that conversion for you. They have a huge table that says, if you've got this data type, it's going to end up as this data type. And if it turns out that's not going to work for you, you can change that query that we were doing to cast columns into a data type that you might want. You might have also thought, what happens if the people table changes? What happens if you add a column or delete a column or change a constraint? There's a lot to talk about here, but the quick answer is that in a lot of cases, Kafka is just going to handle that, and that's actually a configurable option. But in the case that it doesn't handle it, what I really recommend is to not use select star. Use select your exact column names, call them out specifically. That way, if someone adds a new column, you don't get impacted by it. And if someone deletes a column, that's another problem. But those are usually bigger changes that get discussed in depth. Finally here, near the end of my time, so I'm going to wrap up with resources. These are all blog posts and videos and talks that I turn to a lot when researching this topic. A lot of them come from one person who works for Confluent. His name is Robin Moffat, who has a long history both with Kafka and with Oracle, so has really good deep dives into this subject. Then finally, links for this talk. It's been the footer as well the entire time. The video just separate if you want just the demo video. And then some ways of reaching me. Email is great. Slack for either the OIT or the Tech People Slacks are fantastic places to reach out to me. And I'd like to wrap up by saying that with my new job, that talking about Kafka is literally my job, right? So if you have any thoughts on Kafka, questions, concerns, you just want to know more, please do reach out, because talking about this stuff is one of my job responsibilities. So that's it for me. Thanks for giving me this time.